What are two numbers that follow each other and give the sum of 9?
1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 4 equals 7. 4 plus 5 equals 9. The answer is 4 and 5.
Well, this is a normal computer, but a quantum computer would work something like that.
1 plus 3 equals 5 equals 9. The answer is 4 and 5.
This is the main difference between a quantum computer and a normal computer. The quantum computers have the ability to test out many options at the same time, then filter out the right answer, but as fast as possible. Why would we need something like this? A lot of times when running a program, it will take millions of years for us to get the right answer. I'm not talking about simple calculations. I'm talking about sophisticated tasks. For instance, optimization algorithms. An algorithm that tests out every single option to tell us what is the best way to do something. Well, it's all up to something in physics that's called superpositioning. Well, whenever superposition is brought up, they tend to explain it with a quarter. The drawing here is a number 1, and the back of it is the number 0. Once we flip it, we don't actually know what is the 1 and what is the 0. In fact, they are both 1s and 0s at the same time. But once it collapses, it only gives us one specific value. In a nutshell, superposition is when an object can be two values at the same time. Well, what does this have to do with computers? Well, we all know that computers consist of values of zeros and ones, and those are called bits. But quantum computers use something called qubits. Qubits are storing units that use both values zeros and ones at the same time, which I explained earlier as superpositioning. And when a computer uses the qubits, it reduces the time needed to get certain results. Because when a normal computer uses bits, it will have the speed of n to the power 2. But when a qubit is working, it will give the speed of 2 to the power n, which make a big difference. If you have an equation and you plug it in a program in a normal computer, the computer will try to find the solution by plugging in and out every possible answer. But what a quantum computer do enters only the qubits 1. By trial and error, those qubits keep switching places and positions until they reach the right value that gives the true statement. And once it reaches the true statement, those qubits freezes and preserve a certain value that are later on measured. Talking about measurements, measuring the qubits is a bit of a process. First of all, the computers drive those qubits to a cold area called the filter. The filter passes those qubits into a microwave, and that microwave actually measures and determines the magnetic field that caused by a certain qubit and revealing the measured value. And yeah, hope you learned something new in this video.